Hey everybody, it's Kayla and Riley here, and today we're going to talk about solving linear equations. So, linear means we're talking about lines. So all of the equations we're going to be dealing with just have the variable x. They could have the variable k. They could have the variable m. Whatever letter you're using, they're going to have a single variable, so no x squareds, no k cubes, nothing like that. A line is just the variable with, you could say, a little 1 right there. So a line. If we graphed it, all of these equations could have the potential to make a line. We're solving linear equations. See this word right here? Equal. So now they have equal signs. We've been talking about simplifying expressions. Expressions have no equal signs. We're simplifying them. Now we're solving linear equations. Now they have an equal sign. Now you're going to be solving. So your final answers should look like something like x equals 5. So in this part 1 video, we're going to be talking about solving equations, what that means, and solving one-step equations. In the next videos, we're going to be talking about solving multiple-step equations. Video 2, when your variables are on one side. Video 3, talking about when your variables are on both sides of your equal sign. So before we talk about equations and variables and letters, let's first consider a problem that we have done before. So let's consider this rectangle, and let's put dimensions 5 by 12. Okay, so if my dimensions are 5 by 12, and I wanted to figure out what's the area inside this rectangle, well, I would do 5 times 12 equals 60. So the area inside my rectangle is equal to 60. Okay, and because we're talking about area, we usually put units, but for the sake of this problem, let's not attach any letters on it. So it'd be 60. Okay, so let's work backwards. Let's say instead, let's get rid of these. We're going to work backwards. And instead, I say to you, I have a rectangle. I know one side length is 5. I'm going to tell you now the area inside is 100. Okay? We don't know what this length is right here. So now we're saying 5 times what equals to 100. So this 5 times what equals to 100, instead of having to write this question mark, instead let's stick in a variable. Okay, we talked about a variable just as a letter. A letter is representing a number that's unknown. So we're going to say 5L equals 100. A recap, anytime you have a number touching a letter, that means to multiply. So now we're saying 5 times what gives you 100. So there's a few ways we can do it. We could either guess and check. I could say 5 times 10. Well, 5 times 10 gives me 50. That doesn't work. 5 times 15, 5 times 20. Oh yeah, 5 times 20 does work. That's my answer. So that's one approach. But now we're getting into algebra. So algebra. So from now on, we want to solve any of these types of problems using algebra. So if you have a variable, an equal sign, an equation, we're going to be doing algebra. So when we do algebra, we're essentially undoing the operation. The equation says 5 times L gives me 100, so we want to do the opposite operation. I like to always put a line down the equal sign, so my equal sign always stays on that line. So the opposite of multiplying is to divide. I'm also going to show division with a fraction. So divide by 5, I could have written divide by 5, but with algebra, I think it's better to show division using a fraction. So if I divide by 5 on the left-hand side, 5 divided by 5 gives me 1. 1 times L is equal to L. All right, so when we're doing equations, I want you to visually think about, this is like a scale. This is going to be a horrible picture of a scale. But right now, my equation is now off. I've taken away 5, or I've divided 5 on one side. My scale is off. But it's an equation. It has to be equal. So whatever I do to one side, I have to do to the other side. So 100 divided by 5 equals to 20. So does that make sense? Does 5 times 20 give me 100? Yes, I've solved it. That's using algebra. So when we do algebra, we're doing reverse operations. Whatever's given to you in the problem, you're doing the opposite. You're also doing it to both sides because it's an equation. All right, so let's write down a couple rules. Okay, so I said that because we multiplied by 5, we have to divide by 5. So what happens when you add? So if we're adding, the opposite operation is to subtract. And we're going to be doing some examples, but if you want to write this down, so opposite operations. So if the problem gives you addition, you're going to do subtraction. If the problem gives you subtraction, you're going to do addition. If it's multiply, you are going to divide. Okay? And the other thing that you always want to keep in mind is the golden rule of equality. So we're going to do the golden rule of equality. So golden rule of equality basically it says whatever you do to one side, you have to do to the other. So I'm going to say do the same to both sides of your equals. So on both sides of your equal sign, you're going to do the same thing. All right, so let's get into some examples. And keep in mind, the examples we're going to do in this video are just when you have one operation. Okay, in the next two videos, we're going to talk about when you have more than one operation and you have to do more than one step to solve it. All right, and also if you have colored markers, I'm going to use the same operations in the same colors. So let's start with the first one. I have x plus 2 equals 8. And I'm going to do two problems right next to each other. So the first problem is going to be x plus 2 equals 8. The next problem is going to be x minus 2 equals 8, so that we can see the difference between those two problems. All right, so I like to draw a line down my equal sign. Let's put a little squiggle just so we can see those are two separate problems. Okay, so in the first problem, my goal is I want x by itself. And I want to look just on this side of the equation. What's standing in the way of that x being by itself? That 2. What's the operation that's happening? I'm adding 2. What's the opposite of adding 2? That's subtracting 2. Okay, so when I do 2 minus 2, that makes 0. X plus 0, that's x. So on the left-hand side, I've got an x alone. The golden rule of equality, whatever I do to one side, I have to do to the other. 8 minus 2 is equal to 6. That's our final answer. Let's check it. Is 6 plus 2 equal to 8? Yes, it is. All right, the next one. Now I have x minus 2 equals to 8. I want my x to be all by itself. What's standing in the way? That 2. What is that 2 doing? It's subtracting. The opposite operation is adding. I'm going to add it to both sides. On the left-hand side, negative 2 plus 2, that cancels to make 0. That means on the left-hand side, I just have x. On the right-hand side, 8 plus 2 is equal to 10. Let's check it. Does 10 minus 2 equal to 8? Yes, that does. So, in both of these examples, when I add 2 and subtract 2, or subtract 2 and add 2, these are called the additive inverses. So, additive inverse property. And what that says is that when I add 2 and subtract 2, it cancels and makes 0. And I can use that to solve by just bringing down x alone. Alright, so let's move on to what happens if you have multiply or divide in front of your x. Alright, so if you have a blue pen or a different color pen, we're going to show it in a different color. So we're going to show 2x equals 8 over here, and a negative 2x equals 8 over here. Another thing to point out is that I'm showing x on the left-hand side, but x does not always have to be on the left-hand side. So I'm going to put a line through my equal sign. I know that x is going to be over here, and I want to know how can I have x be by itself? What's standing in the way of x being by itself? This 2. What's the operation? Well, these are being multiplied. Opposite of multiply is to divide. When I divide, 2 divided by 2, I get 1. So, when we added or subtracted, we canceled and got 0. When you multiply and divide, you want to make sure that your numbers cancel to make 1. So, I have to do both sides. That's my rule using algebra. 8 divided by 2 is equal to 4. Let's make sure this makes sense. 2 times 4 equals 8? Yeah, that works. Alright, down here, what's standing in the way of my x being by itself? This 2, this negative 2. What's happening? Well, this negative 2 is being multiplied. The opposite of multiplying by a negative 2 is dividing by a negative 2. Be careful when you do division that your numbers match up. If I'm multiplying by a negative 2, by a positive 2, I'm dividing by a positive 2. If I'm multiplying by a negative 2, I'm also dividing by a negative 2. These numbers have to cancel to give you 1. Negative 2 divided by negative 2 gives me a positive 1. 1x, that's just x. Both sides have to get divided by the same number. Whatever I do to one side, I have to do to the other side. A positive divided by a negative is a negative. So this rule right here, which also applies for when we divide, is called the multiplicative inverse property. And our goal with this is that when I'm multiplying or dividing, I want to be able to cancel my coefficient, the number in front of my x, so that I get 1. And make sure that when you cancel, your sign corresponds. Okay, so I'm not dividing a positive by a negative, they match up exactly. And I'm getting 1. Lay down! I know, someone dropped their bone. Oh, found it. There it is. Alright, so we've done adding, we've done subtracting, we've done multiplying, but we haven't done anything with division yet. So, if I have x over 4 equals to 8, this still falls under that same category, the multiplicative inverse. X equals. So this says x divided by 4 gives me 8. How do I get rid of a 4 on the bottom? Well, a 4 on the bottom means to divide. The opposite of division is multiplication. So I'm going to multiply. By multiplying, that number is going on the top. 4 divided by 4 gives me 1. That's your multiplicative inverse. 4 divided by 4 is giving me 1. I'm really multiplying. Whatever I have to multiply one side by, I have to multiply the other side by. Let's show a check on this one. So we've just been visually seeing what a check looks like, but let's do a check. So when we check, we're going to rewrite the original problem. And now let's put in what we have. So we're saying is 32 over 4 equal to 8? Yeah, 8 equals 8. So we know that our answer is correct. Okay, we're going to do a couple more. Okay, so I promise you that the variable does not always have to be on the left, nor does it always have to be x. So let's switch it up. Negative 4 equals, we'll do a k for Kaylin, minus 3. Okay, so for one step, you can always just drop down your variable. Okay, and I want to look what's standing in the way of my k being by itself. This minus 3. This minus 3 is being subtracted. The opposite operation of subtracting 3 is to add 3. Whatever I do to one side, let's first cancel those actually. So negative 3 plus 3 is 0. Bring down the k. Whatever I do to one side, we got to do to the other side. Negative 4 plus 3, that gives me a negative 1. Okay, we'll just visually check it. Negative 4 equals to negative 1 minus 3. Yep, that works. All right, we'll do one more. All right, so we've got 15 equals